Hi there. Let us now discuss the solutions to the exercises in Algebra 1. For the first one, which of the following is not a real number? Square root of 2. Is that a real number or not? Recall that square root of 2 is an irrational number, so therefore it is a real number. Letter B, 1/2, is a rational number, therefore it is a real number also. For letter C, fifth root of -10, recall that if the index is odd, the number inside the radical sign is negative, it is still a real number. However, for letter B, square root of -1, there is no real number whose square root is -1. So this is the answer, letter D. Square root of -1 is an imaginary number. For the second number, we just have to use which principle? PEMDAS. So we have a lot of parentheses here. What's the first thing that we have to do? Everything inside the parenthesis sign. So I have 8 minus 6 here, plus 5 times -4 is -20. I'll just copy it first. What else? -12. Alright, what's next? So inside this bracket, so I have -20 plus 2, right? 12 minus, and then I have -18. I have a negative there. And then what's next? I have an exponent here. So divided by 9. So this actually becomes plus 18. Then inside this, we have addition and division. Let's do division first. So 18 divided by 9 is 2. So 12 plus 2. So we get 20 minus 14. So the answer is 6. For this one, we simply use laws of exponents. So we have 4x cubed y squared times, distribute the exponent 2, we get 9x 4y squared. Can now multiply, so 4 and 9, we get 36. X cubed times x4 is x7. Y squared times y squared is y4. So the answer is letter B. Next, what is the result if x plus 10 over 2 is subtracted from x over 2 plus 10? Take note of this phrase there, subtracted from. So meaning to say, when we perform subtraction, where will we start? We start with the phrase after from. So this is simply x over 2 plus 10. We start with that. Minus the entire x plus 10 over 2. Okay? However, this is minus x over 2 plus 5, right? Then when we remove the parentheses, we get minus x over 2 minus 5. X over 2 minus x over 2 gets cancelled. The answer is 5. Letter B. Next, if for all real values of x plus 1 times x plus a is equal to x squared plus 6x plus a, find a. If we look at the left-hand side, when we expand, what will we get? We have x squared plus x plus ax plus a equals x squared, the right-hand side, 6x plus a. So we cancel x squared and x squared, a and a, so we have x plus ax equals 6x. What does that mean? So that means for x plus ax to be equal to 6x, that means that a should be equal to 5, right? So that x plus 5x equals 6x. The answer is letter D. Next, if x is a real number such that the absolute value of 5 minus x is less than or equal to 2, which of the following is true about the values of x? In order to answer this question, we have to simplify first absolute value of 5 minus x less than or equal to 2. So let us recall, how do we remove the absolute value sign? If we have less than or equal to, what happens is that the number inside your absolute value gets sandwiched by 2 and negative 2, meaning to say we have 5 minus x is between negative 2 and 2. Since we're solving for x, we have to isolate it. We subtract 5 everywhere to get rid of 5. We have negative 7, negative x less than negative 3. I'm dividing both sides by negative 1, so I get x 3, 7. So what we want is an inequality which is the same as x is greater than or equal to 3 but less than or equal to 7. As you can see, letter A cannot be the answer. They're not the same. Let's look at letter B. In this case, we just have to add 2 to solve for x. If that's the case, we get x, but in this case, we get negative 5 plus 2, negative 3, which is not what we want. So we proceed with the next choice. Let's look at x plus 1 over 2, 2 less than or equal to 4. To solve for x, we multiply everything by the denominator 2. We get 4, x plus 1, 8. We're solving for x and I have a plus 1 here, so subtract 1 everywhere. I now get, and this is exactly what we want. X is between 3 and 7 inclusive. So the answer is letter C. Alright, so for this next example, we want to divide this to RAEs. Let's now solve. If we take a look at this one over here, the numerator and denominator involves more than 3 terms. So that means we have to proceed by grouping. So let's first factor 5x plus 5y minus x squared minus xy. So I will now group the first two terms, 5x and 5y, and then x squared minus xy. Now take note that if you have a minus sign in front of your parenthesis, don't forget to change the sign of the term after the first term. So in this case, the minus xy will become plus xy. Why do we need to do that? To make sure that we're not changing the original expression. Note that if I distribute the minus sign, I have this will again be 5x plus 5y minus x squared minus xy, which is exactly the original expression. Okay, so let me just erase that. I just wanted to show you that you really have to change the sign after the first term. Okay, so for this two terms over here, let's factor this one. So we have a GCF of 5. I have a GCF of 5. Oops, 5 and then x plus y minus, factor out x, and then this is x plus y. Now the goal of grouping is to have GCF in this case. So we now factor out again x plus y. So that's x plus y. And we're left with 5 minus x. So that's the factorization of the numerator. So that's our numerator. Now for the denominator, they're almost the same except that this is plus. Okay? So if you just proceed like what I did a while ago, you will end up with x plus y 5 plus x. Alright, so let me now write the factored version. So this is x plus y 5 minus x over x plus y 5 plus x divided by 2 x minus 5. So remember that whenever you're dealing with RAEs, always factor everything. Okay, the numerator and the denominator. For the denominator, we have difference of two squares, x minus 5 times x plus 5. Now, for this one, I can already cancel my x plus y. Then we have 5 minus x, 5 plus x, and then division becomes multiplication, and then get the reciprocal. X minus 5, x plus 5, 2, x minus 5. So we can now cancel x minus 5, x minus 5. 5 plus x is the same as x plus 5. So our answer is 5 minus x over 2. For this next example, we have a negative exponent. So remember that we need to always remove the negative exponents. X to the negative 1 means 1 over x, and then times y. Again, I have 1 over x plus y. So the numerator becomes y over x all over 1 over x plus y. So we just have a complex fraction. How do we attack complex fractions again? Turn the numerator and the denominator into single fractions. Our numerator is already a single fraction, so let's just copy y over x. And then for the denominator, LCD is x. So we have 1 plus y. So we now get y over x. And then change division to multiplication. Reciprocal x over 1 plus y. So we can now cancel x. We're left with y over 1 plus y. Now take note, I just want to write this as a warning. So for most students, what they always do is whenever they see negative exponents, they just put them in the, like, if it's in the numerator, they automatically put it in the denominator and vice versa. However, you can only do that if the operations in your numerator and denominator are all multiplication. So what I'm trying to say is that, for example, this one, x inverse y over x inverse plus y. For x inverse here, you can actually put it there. But you cannot put the x inverse here and then make it x here and then like that. That is wrong. What happened there? You cannot do that because you have an addition here in your denominator. Okay? But if you had, let's say, x inverse y, z inverse w, the factors, I'm sorry, the operations in your numerator is just multiplication. So if that's the case, you can easily do that. Put the x in the denominator, put the z in the denominator. Z, y, w. Okay? Now, for the next example, we have a squared plus b squared equals 8 and ab equals negative 2. Then the square of a plus b is what? All right. Now, actually, we don't need to solve for a and b here to find the numerical value of the square of 8 plus b. Take note that these terms over here appear in the expansion of the square of a plus b. So let's do that. Expand a plus b, that is a squared plus 2ab plus b squared. And I can now put a squared and b squared together, the 2ab here as the last term. Now we have the numerical value of a squared plus b squared, which is 8. So I put an 8 there. AB is negative 2. So we get 8 minus 4. So the answer is 4. Letter A. For our last example, we want to find the complete factorization of 1 plus 8 over x to the 9. Now, since this is a binomial, our only options are DOTC, dots, and SOTC. But definitely, it can't be this 2 over here because this is not a difference, rather a sum. So it's already an SOTC. If it's an SOTC, how does it look like? It's a binomial, right? Times a trinomial. So just by looking at your choices here, automatically the answer is letter B. So I did not do anything there. So that will save you time. However, if there are other choices which involves binomial and another trinomial, then you really have to solve. Now let's just solve this one just so that you can see that it's really the right answer. 1 plus 8 over x to the 9. So write it first since we already know that it is an SOTC, cube of something plus cube of something. 1 is the cube of itself, 1. 8 over x9. What will I write inside? This is the cube of 2 over x cubed. So we now just get these two terms inside our parentheses. We're left with 1 plus 2 over x cubed. And then, now take a look at this one. What's that again? You square the first term. If the sign here is plus, you put a minus here. And then product of the two terms. So 1 times 2 over x cubed. So 2 over x cubed plus square the last term. So we get 4 over x to the 6. And that's exactly our answer.